So let's take these inverse trigonometric function derivatives one last step. Using a similar process to the one that I found my arcsine function for, we have some general formulas that can be found in your textbook for each of our 6 inverse trigonometric functions: arcsine, arctangent, arcsecant, and arccosine, arccotangent, arccosecant of some differentiable function u. And the functions each look a little bit different right here, and I am leaving the proofs to you as an exercise. However, we can use these, illustrate each of these functions right here using their derivative formulas to help us out. And let's take on this derivative right here. F of x equals the arctangent of the square root of x. Now there's an interesting one. What could we say? Well, that means we're going to use this formula right here, the arctangent of u, where in this case u is going to be our square root of x. Well, if we work that out, let's work this out ahead of time. I always like doing that. Let's get u prime first, right? We know that x, square root of x, is the same thing as x to the 1/2 power. And so when we take our derivative, u prime will be 1/2 x to the negative 1/2 power, which is to say 1/2 times the square root of x, and we'll use that in our derivative. F prime of x, using our formula for the arctangent of u, is going to be equal to u prime times 1 over 1 plus u squared. I actually like rewriting it in this form, 1 over 1 plus u squared times u prime. I keep that u prime separate because you'll see what's going to happen right here. If I take 1 divided by 1 plus u, which is our square root of x, squared, and multiply it by u prime, which is 1 over 2 times the square root of x, let's take a look at what's going to happen right here. We're going to end up with a single fraction, 1 divided by the quantity, 1 plus x, times 2 times the square root of x. I'll take that 2 and I'll move it in front. I'll just take the square root of x and put it back here. And here is our derivative of the arctangent of the square root of x. And that's pretty cool that we can do that so quickly just using one of these formulas.